Hello and welcome to another thermochemistry example. Tonight I'd like to do a calorimetry problem similar to what we're doing in the laboratory. In this example, 100 milliliters of a half molar hydrochloric acid solution is combined with 0.2573 grams of magnesium in a coffee cup calorimeter. The temperature increases 22 degrees Celsius. We need to calculate out the delta H for this reaction. 1 mole of magnesium solid plus 2 moles of aqueous hydrochloric acid will produce 1 mole of hydrogen gas and 1 mole of aqueous magnesium chloride. We're given some very useful information in this problem. The solution density is 1.02 grams per mil. The specific heat of the solution is 4.06 joules per gram degree C, and the heat capacity of the calorimeter is 20 joules per degree C. Now, in order to start this problem, we have to remember the fundamental heat exchange relationship. The heat of the reaction, Q of the reaction, is going to be equal to negative Q of the solution, and in this case, we're going to add the Q, the heat of the calorimeter. Sometimes the heat of the calorimeter is given in the problem, and sometimes it's negated. In this case, since we're doing it in the laboratory, we know the heat capacity of the styrofoam calorimeter. Expanding upon each of the heats in this reaction, the mass of the solution times the specific heat of the solution times delta T of the solution, I'll put that in brackets, plus the heat capacity of the calorimeter, CCal, times delta T of the solution, and the brackets. So now I can start plugging in the variables. For the mass of the solution, we can easily find the mass of the solution by multiplying 100 times the density of 1.02 grams per mil. If we have 100 mils of solution, the milliliters will cancel, and I will get 102 grams of solution. Adding in the 0.25 grams of the magnesium, that rounds out to be about 102.3 grams for the solution. So plugging that in for the mass of the solution, 102.3 grams for the solution. We're going to multiply that by the given specific heat of the solution, which is 4.06 joules per gram times degree C, and the heat change, the delta T for the solution is 22 degrees C. So we're multiplying all that together. We'll add to that the heat of the calorimeter, the heat capacity of the calorimeter, which is 20 joules per degree C, times our 22 degrees C temperature change. Plugging that into the calculator, let's see, for the left-hand side, I got 102.3 times 4.06 times 22. I get 9,137. And that's going to be joules because the grams and degrees C are all going to cancel. Plus 20 times 22, which is 440. And now we can add that together, 9137 plus 440, I get 9,577. Don't forget that there's a negative in here, and it is negative 9,577 joules. So that is going to be the Q of the reaction. Now, most of these delta H's are in kilojoules, so I'm going to convert this to kilojoules right away. Coming down, that's going to be 9.577 kilojoules, negative. Negative because it is exothermic. Now, when you look at this problem, let's go back and take a look. The balanced chemical equation shows that the HCl has 2 moles reacting for every 1 mole of magnesium. We have the mass of the magnesium, 0.2573 grams, and we have the volume, 100 mils of a half molar HCl solution. So we have two reactants and we have ways to get into moles. Therefore, this is a limiting reactant problem. One of them will run out first, and we can start doing these calculations now. Taking a look at the magnesium, we have, if I wrote this down correctly, 0.2573 grams of magnesium to start with. Multiply that by the molar mass, so 1 mole of magnesium over 23 or 24.31 grams. That cancels out grams of magnesium, and I have 0.01058 moles of magnesium. Now I want to work with the hydrochloric acid. I know I have 0.1 liters of HCl. Multiply that by the molarity. The molarity in this case is 0.5 molar, which is 0.5 moles of HCl per liter. That will cancel out liters of HCl. And now I'm going to convert this into magnesium based on the stoichiometry of the problem, because I want to see how much magnesium is required by this half molar HCl solution, this 100 mils. So in the problem, I know there is 1 mole of magnesium for every 2 moles of HCl, and that is from the balanced chemical equation. And when I do the math here, I get 0.025 moles of magnesium. So this volume of HCl, this 0.1 liter HCl at half molar strength, would require 0.025 moles of magnesium to completely react. We have way less than that. We only have 0.01058 moles of magnesium. That means the limiting reactant in this problem is the magnesium. So when I calculate out my delta H for this reaction, I will divide by the moles of magnesium. So remember that the delta H of the reaction is going to be equal to the Q, the heat of the reaction, divided by the moles of what you're working with. In this case, we're working with the magnesium because it is the limiting reagent. So we have negative 9.557 kilojoules. We'll divide that by 0.01058 moles of magnesium. So 9.577, divide that by 0.01058 moles, and I get 905 kilojoules. And remember, this is negative, it is exothermic, per mole of magnesium. And that is the answer. I hope you find this example helpful. Thank you very much.